If you drop below the waves and descend into the water column, the familiar world of sunlight and shorelines quickly slips away. You enter an entirely different planet that exists right beneath our own. We currently possess higher resolution maps of the dry, desolate surface of Mars than we do of our own ocean floor. This diagram shows exactly how immense that physical blind spot is. The ocean accounts for roughly 99.5% of all habitable space on Earth by volume, yet we have mapped less than a quarter of the seafloor in any meaningful detail. When we catalog the life inside that space, the numbers drop even further. Biologists estimate the ocean holds up to 2 million species. We have formally identified fewer than 250,000 of them. Over 80% of marine life remains entirely unknown to science, living and dying in a massive ecosystem we have barely visited. Drop below 200 meters and you enter the midnight zone. Total darkness. To navigate and communicate, an estimated 76% of the species down here produce their own biological light, making bioluminescence the most common form of communication on Earth by volume. This is the habitat of the colossal squid. It can grow up to 7 meters long, navigating the freezing dark with eyes the size of dinner plates, the largest eyes of any known animal. Biologists knew this massive invertebrate existed for exactly 100 years, but until very recently, every single specimen ever studied was found dead, either washed up on beaches, tangled in deep-water fishing nets, or pulled from sperm whale stomachs in pieces. That changed in April 2025. During an expedition in the South Atlantic, a remotely operated vehicle exploring 600 meters down recorded a 30-centimeter juvenile. It was the first time in human history a colossal squid had ever been filmed alive in its natural habitat. A massive apex predator managed to elude direct human observation for a full century. That track record proves how easily the midnight zone can conceal heavy, complex biology. In 1950, a commercial whaling expedition operating in Antarctic waters processed a sperm whale. Inside its stomach, the crew found a small, relatively intact squid. That tiny specimen was submerged in preservative fluid, shipped to a museum collection, placed in a drawer, and ignored for 75 years. In 2025, researchers conducting a taxonomic review finally examined it closely. Its morphology was so unique that it didn't belong to any recognized genus or species. They had to create an entirely new biological family, the Mobidicidae, to classify this single animal, which they named Poseidon squid. We are so disconnected from the deep sea that entirely new branches of the evolutionary tree sit unrecognized in our own filing cabinets for decades. In 2023, a deep-sea rover mapping the Gulf of Alaska 2 miles down recorded a strange, domed, golden object with a hole in the center. Marine biologists had absolutely no idea what it was. It took nearly 3 years of whole genome sequencing to identify it in April 2026. The golden orb was the residual anchor tissue of a giant deep-sea anemone, Relicanthus daphniae. The species is so poorly documented that its isolated tissue looked like alien biology. Discoveries are compounding rapidly. Late 2025 saw 14 new species pulled from 6,000 meters down. Then, an expedition mapping the Clarion-Clipperton Zone in the Pacific returned with 24 newly identified species of amphipods. Among those 24 new amphipods, the researchers identified a completely new superfamily. They found a structural division in the lineage of marine biology that we simply did not know existed. Every time we drop a camera into the deep ocean, we find biology that forces us to expand our taxonomic frameworks. To reach the deepest points of the ocean floor, you have to survive 1,100 atmospheres of pressure, the equivalent of a large car resting on every square centimeter of your body. Temperatures hover near freezing, supporting organisms like the Greenland shark that can live for 5 centuries. But scattered across the seafloor are hydrothermal vents, where geothermally heated water violently erupts at temperatures up to 400 degrees Celsius. Entire ecosystems thrive in this boiling, toxic water. They rely on chemosynthesis, a biological process where bacteria convert hydrogen sulfide and methane directly into energy. These extremophiles, organisms that thrive in severe environments, survive independently of sunlight. The existence of chemosynthesis proves life can flourish in dark, high-pressure, chemical-rich water. That makes the deep ocean our primary model for the subsurface oceans currently hiding beneath the ice of moons orbiting Saturn and Jupiter. The depths of our own oceans serve as the template for life across the solar system. We are searching the stars for biology that is likely thriving, completely